Hi. Good morning or good afternoon, depending on where you're logging in from. Welcome, everybody, to our webinar. This is Dynamic Routing at 1 million messages per second with Spring Integration. I'm the guy on the bottom of that slide there, Josh Long. Nice to meet you. We'll hear from the one and only John Davies in a few minutes. John, do you want to say hi?
Yeah. Hi, guys. I'm here. How are you doing?
As Amy was nice enough to mention, please don't hesitate to ask questions. We're happy to answer them in the Q&A section in the WebEx while we're going. So, back and forth, we'll dispatch. Okay, so moving on. I just wanted to give a kind of a quick primer introducing Spring Integration. Spring Integration is an enterprise application integration framework. I think David Linthicum has a really nice, if a bit drawn-out definition for what EAI is. He says that EAI encompasses approaches, methodologies, standards, and technologies allowing very diverse but important systems to share information, processes, and behavior in support of the core business. All of this to say EAI is a way to share data and services between systems, between applications, okay? EAI is best described in Bobby Hope and Gregor Wolf's canonical book, Enterprise Integration Patterns. Martin Fowler also talks about some of the common integration patterns as well in his Patterns of Enterprise Application Architecture. Four very common patterns for enterprise application integration fall out of those books. They're file transfer, shared database, RPC, and messaging. File transfer, of course, is, it's the best kept secret of integration, which is a lot of people, a lot of different systems work and still work to this day very much in terms of batch files, right? So you put a file on a FTP or a mount or an NFS mount or an SFTP mount or, via AS2 or something, and then the other party processes that file. So that's the shared state between the two systems. That's the interface between the two systems is a well-known file format and a file itself. Another common pattern for integrating between systems is shared database, whereupon two parties converge upon the same table or view inside of a database for their information. This is something of an anti-pattern. I think most people today would probably thumb their noses at this approach, but again, you'd be surprised how often you can see that out in the wild, Integration isn't always clean and sexy. Remote procedural call is, of course, I think very common. It's probably what a lot of people go to first, and it is, I would argue, the least useful way of doing integration because your interface, your connection between two different systems is in terms of an object interface, right? And that becomes something that's very brittle and hard to maintain as you evolve the API, as you evolve the objects. Messaging is certainly the most common way for integration these days. It's basically pub-sub, or point-to-point messaging between systems using some sort of messaging style. Again, XMPP, SMTP, JMS, AMQP, even tweets, etc. They all lend themselves to thinking in terms of messages, send a message and I get a reply. When we talk about Spring Integration, it obviously serves a gap. It fills a gap in the industry. There are other pieces of software that do similar things, but really, when we talk about Spring Integration, the biggest competitor for Spring Integration isn't some other technology out there. It's the homegrown, bespoke system that a lot of us are sort of likely to build by ourselves, absent some guidance and some useful framework like Spring Integration to help us. So hopefully you don't build this is a Rube Goldberg machine, it shouldn't be that complicated or fragile to string together different systems, Spring Integration is a message bus at its core. The idea here is that you have a spine through which messages are routed, and communication from each component in the system only has to be in terms of speaking to that central message bus. It doesn't have to be in terms of the interface that every other component exposes. So, for example, for component A to talk to component B, that's one connection. If I were to then extend my application to talk to component C, now A would have to know how to speak to both B and C. Well, by routing it through a message bus, I can avoid all that together. I can just speak in terms of A to the message bus, and then the message bus knows how to speak to B, and it knows how to speak to D, and it knows how to speak to C. So the connection is, it's only It's only on the message bus itself that you have this onus of conversion, of adaptation. In the API itself, Spring Integration works in terms of messages, as I say. The interface that you'll work with more often than not looks like this. It's the message interface with a payload of type T, and then a message headers. And the message headers are basically just a glorified Java util.map with some convenience methods. These headers are key values that provide extra information about the payload. So, for example, if you send a file as a payload, a java.io.file, you might expect to find the file name in the headers. When you work with Spring Integration, you end up stitching components together. This is a pipes and filters architecture. It's the same architecture you see on the command line when you do something like this. When you go, cat food.txt and grep the, sort, etc. Right? That's a pipe and filters architecture. You're taking different components that are singly focused that provide one small, they know how to do one thing and they do it very well. And then the boundary between the two of them is, in this case, standard in, standard out. Well, for integration, it's just this channel. It's whatever object, it's whatever message you send on these channels between components. So in this way, you keep the interface lean and mean, and it's easy for components to jump in and start speaking, to these other components because they just have to speak to these channels. There's two different types of channels. There's point-to-point. First, you have one component sending a message to another, and then publish-subscribe. This is one component sending a message to multiple listeners, multiple consumers on the channel. Let's see. When you use Spring Integration, a lot of stuff is already available out of the box. So, for example, you get a lot of components out of the box to help you in your complex messaging and orchestration flows. For example, it's transform a message that comes in from one channel and maybe change the payload or enrich it, add data to it, etc. You can use any of the numerous pre-built transformers. If you want to filter, which is basically like an if statement, if you want to, predicate the values that go through the system and constrain it to just a subset based on some condition, you use a filter, right? And again, imagine for all of these components that a message comes in, something happens, and a message leaves. So input channel, output channel. The router is more like a switch statement. Here you're saying, send this message to the channel that we determined by evaluating some sort of test, okay? And that test is dynamic. It could be a test on the payload itself. It could be a test on the headers. It could be, how high is the NASDAQ today. It could be whatever you want, right? It's up to you. Splitter. The splitter and the aggregator pattern are fairly common. You'll see them across different, verticals in technology with different names, but MapReduce, fork, join, and MapReduce in sort of common massively parallel processing. You'll see fork, join, and workflow, splitter, aggregator, and integration. So basically, a message comes in, you split it into multiple smaller messages, and so, for example, you might imagine a large CSV file being split into one message per row of the CSV file. You might use something like Spring Batch for this. It's very natural. And then the inverse is the aggregation. So suppose you have a series of messages from the same order. These are line items in the same order. You've processed each line item as a separate message, and now you want to collect all of them and reform the order and wait for the entire order to arrive before you continue processing. So you put an aggregator here, and you wait for the messages. Finally, the service activator is kind of like your escape hatch. It's if any of the pre-packaged transformers and filters and splitters and so on don't work for you, and any of the interfaces that you can, any of the POJO APIs or interfaces that we provide that let you plug in your own splitter or router or filter don't work, then you can just use a service activator. This is just basically, when you see service activator, just think it's going to call a Java method for me. It'll pass the input message into my method arguments, and it'll take the return value of that method as the output channel result. So it's an escape hatch. When you work in terms of Spring Integration, you have to get data from somewhere, right? And in the example of this here, I'm actually reading a file from a file system, catting foo.txt. It's being converted into a bunch of standard in lines, and it's getting passed to the grep command. Well, the same is true for integration. You have to get data from somewhere. So you have to normalize it. You have to adapt it, right? It wouldn't be very much of an integration platform if you didn't actually integrate with stuff. So, for example, here, if I want to send a message to a JMS broker, I can send a Spring Integration message over a channel, and then the JMS outbound channel adapter will see the message, convert it to a JMS message, and it'll use the hints you give it in the configuration. Here I'm specifying the JMS stocks destination, and I'm specifying a Spring configured connection factory bean, and it'll send the message to the right backend source. You might use Twitter, or you might use syslog or HDFS or any other different types of things. Yeah. So yes, we do support XMPP messages or tweets or SFTP or file systems or Splunk or there's a large number of them, right? Same is true for the other direction, right? If you want data to come in, usually it's going to come in from something called an inbound channel adapter or a gateway. Here I've got an inbound channel adapter that's going to look for files in a directory, and then every time there's a new file, it'll publish a message with a pointer to the new file, the java.io.file object, as the payload. So you'll again, the component that's downstream of the inbound channel adapter will get a message, a Spring Integration message object, with a file object as a payload and headers that pertain to that file. Here we're polling. We're actually saying scan every 1 second for new files. Some things are more push-centric. So, for example, IMAP idle and JMS can both be told or configured to send a message as soon as it's available. So there's no need for Spring Integration to poll. But other than that, the code that's downstream doesn't have to care. There's nothing. The code that's downstream just knows to expect a java.io.file. It doesn't care about whether you had to poll for it or somebody actually submitted it or whatever, right? So again, loosely coupled along the message interface. In code, this is kind of what it looks like. If you inject a reference to a message channel, let's suppose you've injected a reference to one of the channels we've defined before, I can then very easily create a message of my own sort. Here I can say message builder with payload passing in the POJO. I can set up custom headers, or I can set one of the pre-configured headers. Then call the fluid DSL and just say .build, and I can send that message over the channel there. Let's go ahead and take a quick look at an example of this. I'm going to go show you my desktop here. Okay. Let's see. Oh, I just realized that whole bit when I was talking about pipes and filters, you guys didn't see my desktop. This is what I was referring to. This is a very, very simple example, right? This is something we've all done some sort of, if you're on Unix of any sort, this is going to seem very, very familiar. So this is a pipes and filters model for Bash, and it's the same kind of architecture you deal with when you do enterprise integration, right? Singly focused components, passing data from one to another through a common interface, in this case the pipe. Same with Spring Integration and messages. So I'm in the STS. This is the Eclipse distribution. It's open source. We provided from spring.io. You can download it, of course. It's a superset of the latest and greatest Eclipse, so it's always the latest and greatest. But we add extra plugins that are pre-configured to work and all that. You know how it is. You get Eclipse and you spend a couple hours trying to get everything working and integrated and stable. Why bother? We have people on staff whose sole job it is to lose their hair making this work for you. So there's no reason you have to waste time. One of the many nice features is that I can go to the File New menu here and choose from these different channels for getting started projects, right? I can go to File New Spring Project, and then, thank you, go to File New Spring Project, go to the Integration subfolder, and I can choose some different integration starters. So I can say File or Simple or whatever. In my case, I've already got a file example, so we'll go ahead and look at that. This example's already been, I've just followed the dialog and spared you the minute or two to do all that live. The code is fairly simple. If I open up the integration XML, you can see the source here is, again, it's approachable, right? So it's inbound channel adapter, sends a message to the transformer, which transforms the data from a file object into something that can be logged, and then, going on down the stream here, we actually it gets passed through a routing channel where we have a wiretap, which will actually take every message that goes through the channel and then print it out, right? And this doesn't interrupt the flow. It's more like just like in plumbing. It's a tap. It's a chute from which data that's going through can be drawn for sampling. Once it's transited through the routing channel, it'll go to the header value router, which will look at the contents of the message, and then based on some predicate, in this case the mapping of of a header value. In this case, we're saying if the header value is CSV, then go ahead and route it to the CSV files out. If it's XML files, if it's an XML file, then send it to the XML files out, etc. And failing that, route it to the default output channel. In this case, the other files out endpoint, sorry, channel. And then here we have the 3 different downstream components that will process each type of file, right? So the fall through, if nothing else matches, one is the other files out. This will be written to the target output other directory. The outbound channel adapter will write to the output XML for the XML files, and then so on for the CSV. And then, of course, here's the configuration of the stuff that we saw in the logging earlier on. I will go here. Okay, targets, output. I think I have.
So, Josh, while you're fiddling around, what sort of performance do you get out of this standard?
Fairly good. I mean, it's just behind the scenes we're just using Java.util, queues, and so on, and these are regular Java objects. So the biggest performance bottleneck is going to lay in, stuff fairly close to the wire here. And of course, at this point, I've got fairly naive handling for the file read. The file reads, of course, you can always do better. We might have used something like Spring Batch to do a better job, I think. Let's see. Of course, it could always be better. Okay, so there's nothing in my CSV, other, or XML directory, and the configuration for this is to look for files in the input directory here, which is right here. That's this directory. So I'm going to go here and go to my command line, and we'll actually start up the application here. So main. This is all commented for documentation purposes, but basically that's the one line you care about. The rest of it is just about keeping a thread open to keep the container running. Run the Java application. It'll go ahead and start up, and it's monitoring now my directory for any new files, and we'll see the behavior when we put something in there. So here, watch -n 1 tree cd output. Okay, that's this. And then here's that. So I'm in the input directory. If I touch, let's show that other directory there as well. In.csv, we should see the data move there. Touch in.xml. Right. And then of course, if we don't have something that matches, you'll see just like that to the other directory. There you go. Okay, so that's a basic integration flow. The nice thing is, if you want to do better, and if you want to speed things up, again, there's the real money, the real value in performance here is fixing the individual exchanges between components, right? So as I mentioned earlier, there's some fairly naive I/O being done here, and of course we're using file system and so on. So that's one place where one vector where you might look to optimize. To learn more about that, I'm going to hand it back to the one, the only, the main man, John. Okay, with any luck, make presenter. Go get him, buddy.
Thank you, Josh. Here we go. So, Josh, can you see my slides? Since you're the only one I can talk to.
Yep, I can
Good.
see your slides, yes, sir.
Okay, let's take you on from here. So, we've seen how the Spring works, Spring integration works. It's been out there for a long, long time. There's an awful lot of people using it, millions literally. And the vast majority of our clients, most of them are large investment banks, use this. And it's sort of interesting because the last year or so we've started to hit some interesting client requirements where the performance has started to hit well into the hundreds of thousands per second. And as Josh, as I sort of pinged him there for a second to sort of say, how do we speed this up? And it's basically, the Spring is going down to Java, and there's a lot of bits you can tune to tune it up. And we quite happily got 20, 30, 40, 50,000 a second through standard Spring integration. And it put the bottleneck quite firmly back into parsing the messages. And I'm going to walk you through some of the sort of the way we got this up to about 1 million a second, show you the process we went through on this. So first of all, why do we need this sort of performance levels? Well, if you're talking about 200,000 a second, it's all very well. Let's say we can process 200,000 a second. We tune it up a little bit. We bung in a few more cores in there. We tune it up a little bit more, and let's say we get 200,000 a second. But one day we get a little peak of 400,000. It's not unusual. We have Thanksgiving, we have new product releases, etc. You've only got to do this for a short while, for maybe an hour or something like that. And if your throughput falls down just a little bit below your maximum, it's going to take you hours, literally hours, to catch up. Now, for those of you that have ordered new gadgets online as they come out, sort of PlayStations or iPhones and bits and pieces, you'll know what happens if you don't get in there immediately. You're waiting for hours and hours, and this is exactly what the problem is. Not only that, but if we look at this sort of throughput, 200,000 messages a second for 1 hour, it's just half, literally of a K, so 500 bytes each. You're looking at about 360 gigabytes of RAM. There's a lot of memory, even for a large server to queue this stuff up. And when designing a system quite recently for a very large manufacturer, software company, etc., obviously the amount of memory for the queues was absolutely critical in this design, and where we, how we design things out. Take this down even slightly lower, and we got 500K a second. Even if we get a small peak for just slightly over for 30 minutes, and it drops down again, we're still looking at 15 minutes delay. Now, you can extend this down to maybe not 30 minutes. We might not get 30 minutes. It might be 30 seconds or even 30 milliseconds. We still have the backlog building up on all these things. It's absolutely critical. What we really need is real time. We cannot afford to have these messages building up. So there's one absolutely sort of essential critical part of any EAI system as we're passing messages through. There's no point in just passing the binary data through, because we need to know what's inside it. We need to parse it in some way. We might not need to parse the entire message, but certainly the header. And we're assuming we're in Java in this particular point, so we need to get the information out of the bits, the bytes, the ASCII, etc., and parse that into Java in some way. So there's some basic steps I've listed out here. You may have some of these. We need to parse the message, or part of the message. We probably need to do some querying. We might need to route it based on the content, so content-based routing. These are all the things that Josh showed you as sort of, that Gregor Hope had sort of quite nicely put into various different, what we call Gregograms. So these are different sort of fundamental features of EAI. We might need to search them. We probably need to serialize, deserialize. We may need to enrich or transform them, and ultimately we'll be writing the messages out onto a command line, into disk, into a report, into in-memory or something like that. But fundamentally, we need to understand a little bit about the message. All this, unfortunately, takes time. So if we take a comma delimited file, and I've simplified this vastly from what we typically deal with, things like FPML, ISO 20002, and these horrible things where you've got literally thousands of fields. We simplify this into comma delimited file. Even that, if we Java bind it, we end up with a lot of strings. So you see in here we've got the serialization version. That's obviously nice and small, but then we got string name, card number, expiry date, transaction date, these things, etc. Each of these, if you can imagine passing, let's say, 500,000 of these, we've got several objects in there. Every time we call the getters and setters, because strings are immutable, create yet more and more strings. So we end up with literally millions of strings being created every single time we pass a message. And as we pass these messages from process to process to process, they may be serialized, deserialized as we go from machine to machine, we're creating yet more messages, and we're back up into the millions again. So message parsing is what's really creating the headache here. And so the bottleneck was, in what we were looking at, was very firmly in the parsing. We hadn't got any bottlenecks at all in the Spring, because Spring is vastly faster than the bottleneck we currently had. So we had a joint client with the Pivotal guys, Spring guys as well, and it was a telco company, and we were looking at implementing the Radius spec, which is RFC 2865, if those want to look it up. It's a binary standard, and if we take a closer look at that, just one little part of it. It's really, for those of you that are old enough to remember the good old days of binary, where we've got the bits labeled 0 to 7, or sometimes 1 to 8. We had integers, unsigned, signed integers compressed into those long words or words, 32-bit words. We have bit fields, so if some bits are there, they represent whether other fields exist or not. It's sort of, there's 77 pages in this particular spec. Not super hard to encode, but there's lots of different specs and lots of different versions of it, and then you have lots of different proprietary bits. So what we did was to model this, and you see on the right-hand side is a representation of our the model in our tool. So the tool is basically just Java binding. It looks very similar to XML, and in fact there's very little difference, if any difference at all, between the binary model and the XML model, other than the fact, obviously, XML has an awful lot more brackets, spaces, indentations, names and metadata in it, whereas the binary model, there's no metadata in it, obviously, because that's defined by the standard. What it did allow us to do was to take these 77 pages, model it, and you can see in there we still have repeating elements. So you've got the one-to-manys, you can see 3 of those down there. We've still got optional elements, so we've got the 0 to 1, where some elements are optional. And what this means is we're very close to what one would typically see today in XML. So we can model quite complex standards, as we've got in this particular one. So we basically produced that. We produced a complete Java object around this. It meant we could basically read in the binary. What was interesting was meant that we could actually read bit fields. So if we created a method, as we see down here, the 4th line down, it says is ABC set. It means that if a particular bit is set, we get a method, and of course in Spring you can test for that. Interestingly, the next major paragraph down, we can actually test for where we've got bits 4 to 6. So it'll be 4, 5, and 6, 3 bits. So it'll be numbers 1 to 7. So we've got a version ID out of 1 to 8 or 0 to 7. We've got a version ID out of that. But what we have to do to get that information out is first to mask it. So we AND it with the mask you see there. Then we'd right shift it 4, and that would give us the version ID. Interestingly, this means that we can go from this rather nasty hex that we spend ages sitting on our screens staring at. We can now access what was previously a pretty complex binary data model directly through Spring. So we can go from this to this. We can now access the content of the binary data through Spring. But I'd like to pause at this particular bit, because what we've now done is we've gone from a very complex binary Y-level protocol to something which is very easy to manipulate and work with in Spring. It also means, however, that if we were to take something like XML, which we can obviously work with Spring, the difference between the XML that we're working with and the binary at the Spring level is there is no difference. What it, however, means that if we extend that slightly, so if we go from XML and we're manipulating XML with Spring, we could potentially represent the XML as a binary model as well, therefore saving quite a lot of space. And that's what I'll lead on to a little bit later. So that was a good start. It meant we could basically take rather complex binary models, we could parse them, we could abstract the Y-level format, and we could access it in Spring. So that was our first goal. It didn't do much for the performance, though, because we were getting about 20,000 messages per second per core, and our goal was to be quite firmly up into the high hundreds of thousands. and that meant quite a lot of machines. And at that sort of level, lots of machines, we add the network, it slows things down, etc. So really was not quite on. So we looked at implementing this in a byte buffer. So there's a little bit of code on the screen. Obviously, you can come back and read this afterwards. It's very, very simple. What a byte buffer does is wrap a raw byte array. So we took the messages, the telco messages, these radius specs. They're a few hundred bytes in size, some varying between 200 or so and about 800, depending what's in them. We took these and we basically put them directly into a byte array. Now, rather than actually reading out the bits and the strings and the numbers, etc., and creating more strings, dates, numbers, obviously longitude, latitudes, all sorts of bits and pieces in there, we actually left them in the byte buffer and did some what we call lazy parsing. Lazy parsing means that we only go and get the data as and when we need it. So if we needed to find a little bit of data such as start time or end time, and it might be encoded as, well, in fact the start time I can tell you was coded as two integers. The first integer was the seconds, the second integer was the milliseconds. Why those two? Well, it's easier to encode that than it is to use IEEE standard formats. It allows much better maths and easier maths to be done. But it meant we could actually pick out the get start time, get end time, and get duration, etc., directly out of the message without having to create intermediate fields. Now, doing this, our message performance went up from about 20,000 seconds per core, which is about 50 microseconds each, to well over, quite comfortably over 1 million a second. So about 1 microsecond, roughly about 50 times faster. Even if we took out the entire content of the message, it was still quite significantly faster than actually creating all of the objects. The interesting part, another interesting part, you can see here is as we basically take out the, there's an example on the right-hand side there, so this is get number of elements. Using the byte buffer, we see data.get2. Now we've got get long, get integer, get double, get all sorts of different getters inside the byte buffer.
Does this benefit from being, does it benefit, so you're not seeking the entire data, right? You're just looking at the header?
Well, in this particular case, there was a header in this message, but because you don't need the metadata, you're not looking through to say, you know, what am I looking for here? What you're actually doing is saying, I know for a fact that the number of elements is the second byte along. Now, most of the data, what you do is put all of the flat fixed size data at the beginning of the message, and you put all of the variable data at the end of the message. All of the stuff in the header, which is the stuff you're most likely to need, you put up front, so it's in a fixed location. Things that you're less likely to need, you'll put further down, because you end up with a slightly higher impact in reading the message, because typically some of the optional fields mean that the position of the fields changes based on whether you do or don't have those fields.
But does the section of optional fields start at a fairly predictable offset, so you can even avoid seeking there if you need to?
Well, what we found from this particular standard was some of the fields start at fairly regular offsets, but as you get further down the message into more and more obscure bits of information, such as very specific user fields, it gets a little bit more complicated, and so you have to calculate 3 or 4 different offsets. But those calculations tend to be integer maths, because they're calculating offsets in bytes, or bits of the bytes as well, rather than anything that's doing too much complicated working out. It's actually often quicker to calculate the offset using a few, read a byte, check how many bits are set in it, move down, etc., etc. So we've optimized that. But it's still quicker than reading the data out, creating an intermediate object, and then having the object being handled internally.
Makes sense, yeah.
We're also able to create composites methods, so you could have. There was no duration in the standard, for example, duration of the call, but you have start time and end time. Start time was start time seconds, and start time milliseconds, and end time was the same. But you could do a get duration, which was obviously the end minus the start, but it also meant you could actually then do Spring integration-based routing or filtering based on duration, which didn't actually exist in the message, which is pretty cool. So what this did was it moved the bottleneck, so we could now parse and query basically at about 1 million a second. It very firmly moved the bottleneck back into Spring, which was a little bit of a headache because obviously we didn't want any particular bottlenecks. And what this turns out to be is when you type payload.duration less than 0.1, because we're looking for all the calls that were cut off very quickly, for example, what that does is it does basically reflection. Now, reflection is pretty fast if you don't need the performance, but it's in this particular case was about 700 nanoseconds. Now, remembering we're parsing at a microsecond each one, which is 1,000 nanoseconds, you've only got to get two sort of get duration and get location, for example, and you start to halve or a third or a quarter of the performance as we go through. So this created a bit of a headache. So we started to look around some different solutions, and we have to actually say discovered or sort of remembered that there's a compiler inside Java 1.6 and onwards. I very rarely get the privilege to play with some of the new features of, Java 1.6 is now no longer supported. So I had to remind a client last night, very late. But this is new because a lot of clients, certainly in the banking industries, tend to not to upgrade to the very latest, all singing, all dancing version of Java. So a lot of them are still working on the old version. So it's quite a privilege to use some of what we call new features. Interestingly, what we can do is what I've given a little example here is an interface called double accessor. Now, if we were to write a piece of code, you look at the code at the bottom where we've got just a small class which does the get duration, which implements my little accessor there, the double accessor. What that effectively means, if we were to write that class, we can access any one of those methods. Now, move this forward very slightly. What we can do is when we get the Spring expression, we could potentially write the class, as we see here. This again is just another quick little example. We can compile it on the fly, and that little piece of code there is basically what you and I used to type on the command line before we had Ant and Maven and various other bits that just made our lives, I'm not sure whether it made it much easier, to be honest, with some of these things. But anyway, that basically gets all the information, compiles it, and creates a little class file. Then we can do class.forName, load it up, and we can now basically execute that as native code, which is in fact exactly what it is. Interesting thing is that this also is picked up by the JIT compiler and is compiled as well, so runs at full native speed as if the code had been compiled rather than queried using reflection. So we went back to the Spring guys, chatting with Adrian Collier about this, and we're talking about, it would be rather interesting if we could look at this. And he said, this chap, Andy Clements, one of our guys, is busy working on this, or has been looking for a reason to use this. He's had it for a long time and looking for a good reason. So had a chat with Andy, and Andy has basically started to implement this inside Spring. So now inside Spring integration, in the releases that we're working with at the moment, we now have the possibility of some of these queries being compiled at runtime. So it looks to see if there's multiple hits on this. There's a lot of caching already in there, naturally, for performance, as you might expect. But when this kicks in, it basically compiles the code, does a class.forName, loads it back up, and off we go. These are some of the numbers that Andy was playing with that we got, just to give you an idea. This is how long it takes basically for an accessor trying to access something. It's similar to the example I showed you earlier. So 5 million iterations goes from about 1 second down to a 30th of a second, which is certainly an increase of about 30 times in here in this case. If we look at method invocation, And again, 5 million iterations. We've gone down from 2 seconds to 1/10 of a second. Again, 20-fold increase in performance there.
Wow, that Andy, for those of you who don't know, is he's one of the ninjas behind the tools, the FTF stuff. And my favorite memory of the guy is I remember in 2009 he was implementing SPEL, the Spring Expression Language, and he had written the first cut of it using Antler, which is a library for building grammars, which then can be turned into a language. And
ANTLR.
Yeah. Great library, right? Terrence Parr from actually San Francisco somewhere. So he'd use that Antler library, which is a great library in of itself. If you're using that, it's a good start. And then the next week, I just remember, again, I'm writing, at this point it was Subversion. I remember checking Subversion fairly frequently to see what's going on in Trunk when in advance of the 3.0 release, from that year. And about a week later, all the Antler code was gone, and he had replaced it with his own hand-rolled parser for SPEL, which is, of course, far less lines of code and far faster. So the guy's a rock star. Deserves a beer.
Quite amazing. Yeah, he's bumped into him quite a few times now, so we're regular emails backwards and forwards working out with these compilers, but this is making a massive difference. I mean, we've gone sort of 50-fold increase in performance in the parsing. We've now got an additional 20+ increase in what's in the query language. So I'll show you some of the numbers at the end, but this is quite an amazing difference. All of the ESBs, EAIs, SOAs, whatever you want to call them, have the same problem. You cannot go directly in from something which is changeable by a human directly into code unless you're going to do code generation. So this is, at the moment, unique to Spring. There is nothing else that we know of except for Spring integration that can give this sort of performance and throughput. So the advantages we're getting now, we can literally parse, compare, route, filter, etc. around 1 microsecond per message. And these are pretty complex messages. We're starting to take these into more and more complex messages into the financial services sort of realms. The complexity of the message doesn't really matter that much because we're doing lazy parsing, so we can actually take very large messages and we can still put these in very fast. So it's still getting the same sort of performance gains, at least on these sort of things. We can do some other interesting things. We can do on-the-fly aggregations. So we could, for example, keep moving averages, minimums, maximums, sums, etc. And rather than having to feed these into a grid, a cache, in-memory database, whatever you want to call it, we can do a lot of this on the fly. We can use the cache far more efficiently because it's not spending its time doing menial tasks, which previously were the best tool to do this. We can actually do it on the outside and use the cache and grid vastly more efficiently. We're getting about sort of 20 to 50 times performance gains on this. Certainly the numbers we were looking at was 50 times. So we're looking at incredible sort of savings in CPU usage, where we can typically put 1 million a second through on a single core. We were hard pushed to do that on 8 cores. Well, in fact, we're getting better performance on 1 than we were on 8 cores. And again, massive difference in CPU usage, the power behind this, and obviously even just the keeping these things cool. Other advantages we're getting, because we're now encoding these into byte buffers, they occupy a fraction of the space that we had before. So the sort of compression that we're seeing out of this, compared with if you take that comma delimited file, we can take the comma delimited file, and that was a very, very simple example, but as bound Java, that was about 700 bytes. This now goes down to around 50 to 60 bytes on this. So we're looking at around 12-fold increase or decrease in memory usage, which is also very significant because memory is currently the single most expensive part of hardware. So more items in your queue, more items in your in-memory grids, better usage of technologies like gigaspaces, Hazelcast, Gemfire, coherence, etc. And this is already making a massive difference. We have started, the reason that we did this was behind Gemfire, and we're already working on that, and that's sort of making a massive difference in the performance. And because we can... Go ahead, Josh.
I was just going to say, what you're encouraging people to do is basically what all the data grids will encourage you to do eventually anyway, which is know the structure and layout of your data and optimize for that layout, optimize for advanced seeks. Don't try and send objects over the wire when you're, at some point you need to work with the low-level bytes.
Yeah, I mean, these guys have put man-years and man-years. I mean, they've all been around, with the exception perhaps of Hazelcast, which is more recent, but they've all been around for a good part of 12, 13 years. These guys have put amazing effort into taking POJOs and sort of storing them efficiently in such a way that they can store them in large amounts of memory and access them. So they're using byte buffers internally. Same with serialization, rather than putting, if you've ever looked at a serialized Java object, all the metadata of the object names goes in there, so they can be deserialized on the fly quite easily, and with dynamic class downloading and things.
Well,
so
Gemfire and Coherence, like Coherence has a POF, and Gemfire has a PBX. It's basically
PBX serializable, And so what we're doing now, we can actually generate the code which actually implements the PBX serializable in Gemfire, for example, which means that we generate the byte buffer with the PBX serializable, which means that there's no extra work needs to be done on the Gemfire side. So we have unbelievably fast serialization inside the caching. And again, I use the word caching lightly because I know these various different vendors like to think of themselves differently as in-memory databases, caches, grids, etc. So I use those words lightly. But customized serialization, you don't need to store all of the metadata inside the serialized Java object. You can basically just output the byte buffer, and this is what these tools do. But we can actually generate that code and implement the interfaces automatically. So huge advantages on that, certainly in performance. So in a nutshell, basically, we've gone from about 20,000 a second on a single core to comfortably over 800,000. We do have quite well over 1 million on these. So about 40 to 50 times increase in performance. We've reduced the memory footprint of the objects now by around 12 times. These are all, I put a little star, these every single architecture, every single case that you look at is going to have different performance and gains on it. But these are sort of early numbers that we're looking at, and it's certainly extremely impressive. And everything that we're doing through the Spring integration can now produce JIT compiled code, and we're getting dynamic. A user can change what they want to see. They can change how they want to route something, and we can see that happening at native speeds. You suddenly say, right, I want to see all of the calls that were less than 1 second or 1.1 seconds, or I want to see all the data that was from this particular geographical area here with geolocation, or I want to process all of the messages in my feed of fixed messages, for example, that are over a particular value or by a particular counterparty. I can do those dynamically at native Java speeds. That's just quite an incredible feat, I think, today. Future coming up very soon. These will be coming out in a library in a new Spring release. As yet, I don't know which one. I don't think anyone does actually at this point. We're looking for full support of some of the standards like ASN.1, which provides multiple different Y-level implementations on this. Interesting thing for us in financial services, ISO 20022 actually has a definition of the entire metadata repository of 45,000 different elements. It's actually defined both in schema and ASN.1, which means that we can actually take these messages and implement them both as XML or as ASN.1, and we can now use the packed binary encoding standard in this, and we can vastly reduce by a factor of about 15 the size of the XML, and by factors of literally dozens the size of the Java that's generated behind these. So that's basically what we're playing with at the moment. These are the Spring tools we play with. As you guys probably know, Spring have rebranded to Spring.io. So there's all of the various different links for you there. That's it from Josh and I. Do feel free to ping us on any of those various methods of communication that are up there.
So, John, I've assigned a few questions for you. Can you see those in your Q&A panel assigned to you?
Let me click on all of my buttons here.
Should be on the right. Where's this Q&A? Underneath chat and participants.
Oh, Q&A. There we go. Huh.
You see my Q&A? There should be a lot of questions assigned to you with answers.
I can, yeah, 6. There we go. Good. Right.
So I've answered as many as I could, but some of these are just, I think you'd be great at.
You're a star. The class that encapsulates the byte buffer is that generated based on the binary contained in the byte buffer? We are, looking at two different ways at the moment. One is to create a completely standalone class which has no other external dependencies, which, as we're generating the code, this is an interesting thing about generating code, is you can make small changes, and those changes are affected with all of the code that you work with. So we can custom generate all of the getters and potentially setters as well, and we can so effectively put the raw message directly into the byte buffer and take the data directly out of that, or we can sorry, someone's disturbing me here. We can put it in its native format. That's one way of doing it. The other way of doing it is just taking the message, and we can encode it in the byte buffer in any particular way we feel like, and that would be one of the options where we'd use ASN.1, for example. Hopefully that's answered that question. Moving on to the next one. We need to log some messages into a database. Writing one message into a database takes a long time. Spring integration processing the message. How to maintain high performance with Spring integration logging into a database? Well, Josh, you could answer this one, but my recommendation on this, we noticed the same sort of thing. This isn't a Spring integration problem. This is just using the different tools for the jobs. If you're writing to a file, for example, the Spring integration gives you a file which basically finds the file, seeks to the end of it, writes it, and then closes the file. Now, of course, if you do that a lot, it's going to be very, very slow. The same would be true for the database. So I would suggest Spring Data or Spring Batch on these sort of things, where you could actually control a little bit more. You'd obviously keep the connections and the connection pools open on this. So I would suggest you look at Spring Data on that side for the performance on that. Josh, have you got any other comments on that?
No, that was my thinking as well. Just wanted to hear what the man says.
You
get it validated.
You know these things better than I do. Is there a custom serialization of message objects with message header and payload? I can persist to storage devices for file data instead of using Java serialization. Yes. Serializations, if you use native Java serialization, it uses reflection, basically goes through the object and looks at all of its attributes. If the attributes are other objects, it then goes through all of those objects and stores all of those bits. But what it also does is put all of the tags, i.e. information about the object, into the serialization as well at the same time, so that if a random object was to pick it up, it could actually sort of reconstruct the object from scratch. So object serialization, A, uses reflection, so it's slightly slow, and B, it uses a lot of metadata, so it's a bit like XML, in that the metadata, rather than sort of being in the definition, is actually sent out with the object itself. So there's a couple of ways you can do that. You can either use externalizable, and you can override the read and write object, which is one way of doing it, or you can completely, well, in fact, that's the best way of doing it, is you can basically override the way that your object is serialized completely. If you know for sure what the object type is, going both in one end and coming out of the other end for serialization, deserialization, you don't need to write all of the metadata in there. Potentially, you could even change that to XML if you wanted to write it to something that was human readable. So there's a lot of scope, but look at externalizable on that one. Again, Josh, any comments?
No, sir. Just serialization is, kind of what we're talking about here today. You gain a lot by thinking about it just a little bit. Spring integration itself doesn't have to change. The serialization, though, can be huge.
Yeah, it's just raw serialization is very slow. Externalizable is basically your way around that. But be careful. It's you're locking stuff into particular versions, and again, writing code generation makes life slightly easier because you're maintaining both sides at the same time. So you need to make sure those are up to scratch. So next question here. Any tool support to generate those rather hairy getters and setters for the defined data structure? Writing them manually would be hard. Yes, absolutely. The thing you should have on the screen at the moment is the C24 side. That's exactly what we're doing. We are using code generation, so we're modeling the message. It's a model-driven architecture. Those models could be maintained as XML schema, for example, or potentially in the future ASN.1. We generate all of the getters and setters. If you're not looking for the high-performance side of things, then we can import and export all of these comma-delimited files, binary, XML, tag value pairs, all of these nasty things, and we generate all of the getters and setters and a lot of utility methods. And going back to the previous question, we generate the customized serialization as well in a number of different formats. So that's what, about 2 or 3 years ago, we integrated with Spring integration, and it was basically what we were trying to do was to extend Spring integration out of just pure Java and XML to extend it into other more complex standards. So that's why the two fit quite nicely together. Another one from Praveen. Can this replace WebSphere MQ integrator? Yes, of course it can. I have a Swift. Message Swift. Yeah, this is right up our street. We started with Swift, basically. So, in fact, to get a little bit of history, our previous company before we started C24 was a company called Braid, which was acquired by Mercator, which became IBM's, what is now their message integrator. So that was our previous company. So our expertise is in Swift. So we take Swift messages and we basically produce Java code for them. And this is exactly what we started doing and what we continue to do at the moment. So for doing transformation into and out of Swift messages from something else, typical client usage is reading flat files into Swift, reading Swift, putting it into databases, reading Swift, adding it, and etc. And those often go into in-memory caches, databases, grids, and of course, most of the clients use Spring integration to do that. So that's hopefully answered that one quite nicely. That was probably a seeded question. Thank you for that one.
I wish it was. Well.
And is Spring integration a good fit for this use case? Yes, absolutely. And the reason, there's a little bit more history behind it, which I won't explain now because we don't have time, but the reason we got so deeply into Spring integration is because the vast majority of our clients were into that. Now, a lot of them obviously use Mule, Fuse, Camel, etc., but in combination of those, they use Swift. They use Spring integration as well, so that's why we got into it. Last question I can see here. Oh no, I've got a lot more. I missed how XML is being converted into packed binary. Good question. The XML is not automatically converted into packed binary. There's no, we haven't got onto that yet. We haven't managed it. The ASN.1 standard is an alternative standard to schema, and for ISO 20022, it is defined in both schema and ASN.1. That doesn't mean there's an automatic swap between the two, so it's not therefore obvious to do that. One of the things we can do is to certainly take out a lot of the metadata out of the XML, so at the moment we can significantly compress it, so to speak, so we take out a lot of the metadata. What we're working towards is a more automated, but hopefully via a standard mechanism to pack the XML. XML is a lot more complicated than most people realize with things like ID refs and substitution groups and such. So we need to be careful that we can handle and implement all of that. Things like FPML, DTTC, Murex, and Calypso, and ISO 20022, etc., are all standards that we need to make sure that we can handle. Are you adding all these, or they just keep arriving? Okay, another one. So the message is binary. You mentioned radius, and you built a custom way to query the message and so forth. What is the code complexity of the custom code, and any chance this code will be shared in any part of the library? The custom code for radius is an open standard. It's an RFC standard. It is quite possible that, in fact, that is owned by Pivotal, because they have the IP on that, because we worked with them. Whether that will go into an open source standard, I'm not sure. That's a good question. So Paolo, who sent that question, if you'd like to email myself or Josh, it might be a question we'd need to check up on whether that could be made available. The custom code is not custom code, it's generated code. So we have defined the radius spec. We've implemented it purely as a model. And we now generate, as I was explaining earlier, all of the code behind this is generated. So it's not custom. We originally started with custom code, and we now generate the code. So if there's any changes to radius, for example, moving into diameter, which is another similar spec, or some of these other things, the code is generated. So that's the big difference on that. We've got another one here. If we already have a messaging system that uses XML, what is the complexity of converting to this packed binary style? Another good question. The code that Josh put up at the beginning in the little demo is exactly the same code that runs 20,000 a second to 1 million a second. The nice part of this is it's all hidden under the hood. The clever Java binding is hidden under the hood, and so it's generated code by the C24 side. The compiler optimization is done again by the clever work that Andy Clement has done inside Spring integration. So again, that's hidden under the hood. So there are very few changes other than a little bit of sort of re-architecting, which is what you need to do anyway to make things run faster. So there is very little change to this. In terms of converting to the packed binary style, again, this is early days yet. There should be nothing, because you're still treating the message as if it was XML rather than the Y-level format. There's a huge difference on that. And that's why we can treat messages which are not, for example, going back to the radius standard, it's a binary message, but we can treat it as if it was XML. So there is no change at the top level. So there are no changes to the code. This is hopefully, again, it's early days yet, hopefully something where the binary packed style will be simply an option for deployment, and will be more at the Y level rather than at the higher level, at the Spring level. Last question, unless they keep popping up. Does this work for Spring for integrating enterprise platforms such as SAP PeopleSoft? Yes, well, not those specifically, because we don't do too much work with SAP and PeopleSoft, but these are in production, have been in production for over 10 years with some very, very large banks. Write yourself I can't mention them, but write yourself a list of the 10 largest banks in the world, and we'd probably be in about 7 or 8 of those, including some of the main federal bodies behind those various organizations for very large countries. So yes, this does definitely work at an enterprise level, and it's been working for a long, long, long time, and they also use Spring integration and C24. Obviously not both in combination, but for well over 10 years. So that's hopefully covered that one. Josh, I've got another one. Here we go. They keep arriving. Generated from what models? What modeling tools support? Another good question. Inside the C24 Studio, there is a modeling tool that allows us to import XML schemas. It allows us to import databases, comma delimited files, Excel spreadsheets, all the sorts of bits and pieces. We can manage, manipulate, model those. It includes things like FPML, ISO 20022, Swift, all the Swift standards since about 2002. Lots of different models. Again, this is in production for well over 10 years now with the world's largest banks. So it's pretty comprehensive in what can and can't be modeled inside this. It stores its metadata as XML. It's non-proprietary, so it's very easy to go in and change it. We provide schemas and bits and pieces for that. So it's a non-proprietary modeling tool that allows you to manage this. And the output of that is you right-click on the root of the model and you just say deploy. There are lots of different options that allow you to deploy it as these smart objects or as slightly less smart objects. And I have to stress that things like XML, if we import a schema, you can't right-click and suddenly export a binary and compressed standard yet. As I say, there's a lot more work to be done before we get there. But we do have this for many of the binary standards and simpler things like comma delimited files at this point, and some work towards the XML.
I just wanted to, nicely done by the way, I just wanted to throw in, somebody was asking about whether we could use the optimizations that Andy's making for the Spring Expression jar, and then which versions they'd be available. Those are 4.1 milestones. That's what we're looking at releasing that in. So you can use 4.1 when it's available with any version of Spring integration, of course, because it's backwards and forwards compatible. But you might even, in theory, be able to just take the Spring Expression jar and use that with Spring 3.2, for example, which is normally a really silly thing to do, but if you really wanted it, Andy says he's 90% confident that might work, but of course, kind of an on-the-fly question, so.
Yeah, and if any of you've got any particular use cases for the Spring Expression compilation, by all means, email us or contact us. And I mean, the more real use cases we get into this, the better, because it'll get tested. This is going into production already. It's going towards production, not yet, but we do have real use cases for this. So. Please feel free to contact us if you've got some other use cases, because that would be great to include those with the work that we're doing.
Right. Okay, I think what do you think? How did we do? Got any other questions?
Any more questions? No.
Okay. Well, this has been fun. Thanks, John. I had fun. Hope you did too.